Hello class, today is the 9th of March, and what we're going to be doing is we're going to be going into a new math lesson. We had just finished up the last math lesson yesterday, so what we're going to be doing is we're going to be moving on to not the next math lesson. We're actually going to skip lesson 3 and go straight to lesson 4. Now, when it's been coming to adding integers when we have positive and negative integers, we've been using a number line in order to help us out. What we're going to be doing today is we're going to be going over, well, what if we don't want to write a number line? What if writing a number line for every single math problem, it's going to take some time. So let's come up with some rules and ideas of what we can do to prevent that, to make it so that we don't need to draw a number line every single time. So for example 1 over here, we're going to be working on making our rule for when we're adding integers with the same signs. Up first, it says, hey, represent the sum of 3 and 5 using arrows on the number line. And, well, this should be pretty easy for us. This is just normal old addition with normal old positive numbers. So we should know, without a doubt, how to do this. The first arrow I'm going to do is for 3. 1, 2, 3. Remember, my arrow is going to stop right there. And then my second arrow is going to go from the end of my last arrow, and it's going to go another 5. So it asks us, well, how long was that arrow that represents 3? Well, that's pretty simple. The arrow that represents 3, that's 3 units long. Which direction does it point? Well, we're dealing with a positive number right now. So our positive numbers point to the right. And if we look at what we have here, well, that's pointing to the right. It's going to go to the right. It asks us, well, how long is our arrow that represents 5? Well, that's super easy. It's 5 long. It represents 5. Of course it's 5 long. And what direction does it point? Well, again, it's a positive number. So this one's pointing to the right. And even if for some reason we couldn't remember that, we've already drawn it. So it's pointing to the right. We can see that. I've redrawn it up here for us just for the purposes of still being able to see it. It then asks us, well, what's the sum? If you remember, in order to find out the sum when we're doing our vector model like this, we need to see where the head of our last arrow lands. So that's going to land right here. That's going to be 8. So our sum is 8. And again, we really shouldn't have had any actual problem with that because, well, these are positive numbers. We're dealing with a positive 3 plus a positive 5. We shouldn't have had any doubts that that was going to be equal to 8. The next part asks us, well, if we were to represent this sum using an arrow, how long would that arrow be and in what direction would it point? Well, my arrow is going to have to go from 0 to 8. So to get from 0 to 8, that arrow is going to be 8 long. And since 8 is to the right of 0, it's going to be 8 to the right. But then it asks, what's the relationship between the arrow representing the number on the number line and the absolute value of that number? Okay, now I'm starting to put together the pieces on why they're asking me all of these questions. Well, my arrow for 3 was 3 units long. The the absolute value of 3 is 3. My arrow representing 5 is 5 units long, and its absolute value is 5. My arrow representing 8 was 8 units long, and the absolute value of 8 is 8. So, what I can say here is that the length of the arrow is equivalent to the absolute value of the number it represents. Now it then asks, hey, do you think that adding two positive numbers will always give you a greater positive number? And hopefully you should know, just through your experiences with adding positive numbers in the past, you should know that, yeah, of course, adding two positive numbers is always going to give us a greater positive number. But we should explain it using our arrows. So what we're going to do is we're going to say, since both arrows go to the right, putting them together will always make a longer arrow pointing to the right. So since no matter what, it will always be to the right, and then even more to the right, it's always going to be a greater positive number. And again, we should know that positive plus a positive is just going to, the number is just going to get bigger. We should know that. Now, we've worked with adding together a positive number and a positive number, but what if we were adding together a negative number plus a negative number? Well, it asks us to represent the sum of -3 plus -5 using arrows that represent -3 and -5 on our number line. Well, we can do that. It's actually going to be very similar to what we've already done. I'm going to take our first arrow. It's going to still start at 0, but we're going to go towards -3. And then I'm going to take my second arrow, and it's going to start where I had left off, and it's going to go 5 still to the left because we're dealing with another negative number. How long is our arrow that represents -3? Well, we went 1, 2, 3 to the left. So the arrow's 3 long. Oh, and it asks what direction does it point. I just said it. It's to the left. We went 3 to the left. How long is our arrow that represents -5? Well, as we know, an arrow that represents -5 should be 5 long, but instead of pointing to the right, it also points to the left. So we've got our arrow that is 3 to the left, and then an arrow that is 5 to the left. But what's the sum of this? Well, once again, to find our sum, we need to find out where the tip of our arrow ends up, the topmost arrow, and it ends up over here at -8, which means that our sum is -8. Then what it wants us to do is, just like we did in that last situation, it's asking us to draw another arrow to represent our sum. So once again, we have to start at 0 and go to -8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8 long. And it's going to be to the left. So 8 to the left. And hopefully, even though it doesn't ask us that specific question again, we should be reminded about how our lengths of our arrows are relating to the absolute value that the arrows are representing. This arrow is 3 units long. The absolute value of -3 is 3. This one is 5 long. And the absolute value of -5 is 5. This one's 8 long. And the absolute value of -8 is 8. So we should still keep those in mind as we look at this question, which asks, hey, do you think that adding two negative numbers will always give you a smaller negative number? AKA, do you think it's always going to be even further to the left? And, well, think about it. Right now, what I have is the fact that we've gone to the left, and then we've gone even further to the left. So it should stand to reason that no matter what, I'm going to keep going further to the left no matter what, because it's to the left and to the left. So like how our answer before was, since they both go to the right, putting them together will always make a longer arrow pointing to the right. This answer can look very similar to that, except instead of since both arrows go to the right, it's going to be that since both arrows go to the left. Putting them together will always make a longer arrow that is pointing to the left. Now, it then asks us, well, what do our examples here have in common? What's so important about these two examples? More importantly, just in terms of these examples, I want to focus more on the sum and the absolute values. So let's think about our absolute values here. For my first example, I had an absolute value that was 3, plus an absolute value that was 5. And when I added them together, I got 8. 3 plus 5 gave me 8. And the absolute value, 3, plus the absolute value, 5, gave me the absolute value, 8. And that should make sense for my positive numbers. But the same happens for my negative numbers. I had -3 plus -5 gave me -8. So the absolute value of my first number, 3, plus the absolute value of my second number, 5, gave me the absolute value of my sum, 8. So 3 plus 5 gave me 8. But since my original numbers were both negative, my sum had to be negative. So I could use my absolute values here to find, okay, how far away from 0 is it? And then after I do that, I can say, okay, now I know that since both of my numbers are negative, I'm always going to get a negative number. So I know that I need to change that to negative. So what we can say here is that the length of the arrow that represents the sum, aka this one over here, the length of this arrow is 8 long. Let's actually make this longer. Specifically, I want to mention that this is the sum of two numbers with the same sign. Because as we'll see a little bit later on, it might not work when we have numbers with different signs. Two numbers with the same sign is the same as the sum of their absolute values. So when I add together the absolute value of my first number and the absolute value of my second number, I get the length of my third arrow. 3 plus 5 gives me 8, and my sum's arrow should be 8 long. So you should look right below this on your own paper. There's a rule there for us. If I add together numbers with the same sign, I can add together their absolute values and just use whatever sign they both have. So for my positives, I can add together the absolute values of my number, and I know that I need to make my answer positive because they were both positive. For my negatives, I have to add together the absolute values of my two numbers, and then since both of my numbers were negative, I need my sum to be negative. So your responsibility right now is you are going to work on exercise 2 independently. And then when you finish, come back to this video and we are going to go through example 2 where we're going to be working on adding with opposite signs. I'll give everybody a few seconds to pause the video and work on that exercise. And then you can unpause this video and come back to it. 3, 2, 1. We're continuing with example 2, which is going to be our rule for what if we're adding numbers that have opposite signs. Well, the best way to find out how to not use a number line is to, well, we're going to use a number line and draw some inferences from it. So we are going to represent 5 plus negative 3 using arrows on our number line, just like what we had done before. So, once again, I'm going to go with my arrow for 5, starting at 0. And then my arrow for negative 3 is going to start where my last arrow ended. It's going to end right there. And then, similar to the questions that they asked us in example 1, it's going to ask us, hey, how long is our arrow that represents 5? Well, I kind of see what they're going to start going towards right now. So it's going to be 5 long. And I remember that's also the absolute value of 5. I have to remember that in my brain. Then it says, well, what direction does it point? Well, representing 5, it's representing a positive number. It's pointing to the right. It's pointing to the right. And it asks us these same questions, but for negative 3. Okay, well, negative 3 is 3 units long. And I need to remember in the back of my head, the absolute value of negative 3 is 3. Remember that in the back of your head. What direction does this one point in? Well, this one's going to point to the left because it's representing a negative number. Negative numbers tell us to go to the left. Once again, just like before, I've redrawn our number line up here just so that I can see it and you can see it in the video. Which arrow is longer, though? Well, let's compare the two lengths. One of them's 5 long, the other one's 3 long. So it's probably the arrow that's 5 long, right? So I could say my arrow that's 5 units long, or I could say my first arrow. My first arrow is going to be longer. And then what's the sum? Well, just like normal, when I want to find the sum, I need to just find where the head of my last arrow lands, and circle it. So my sum is 2. If I was to represent that sum using an arrow, how long would it be and in what direction? Well, it's going to be too long. It's going to be to the right. To get from 0 to 2, I need to go 2 to the right. So I'm going to say it's going to be 2 to the right. Okay. So my longer arrow was my first arrow, the arrow that's pointing to the right. And the arrow that represents my sum is also going to be pointing towards the right. Okay, interesting. Well, let's look at it the other way. This time we're going to represent 4 plus -7. Well, first things first, I need to represent my 4. I start at 0, and it's going to be 4 long. And my second arrow is going to be -7. So it's going to be 7 to the left. So for this one, it doesn't even dally. It doesn't even go into, well, what direction does this arrow go? How long is it? It immediately just asks us, hey, in these two examples, what's the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the two addends? Well, let's look at the length of the arrow that would represent this sum. Well, first of all, what's the sum? It ends at -3. And how long is an arrow that goes to -3 going to be? Oh, let's change that to purple. It's going to be 3 long to the left. So this arrow is 3 long. And it's dealing with an arrow that's 7 long and 4 long. Okay, so what's my relationship between 7, 4, and 3? 4, 7, and 3. 3, 4, and 7. Oh, well, if I take 7 and I take away 4, I'm going to get 3. That's a little strange because 7 is my second number up here. -7 is my second number up here. So it's weird that I'm reversing it. But 7 is my longer arrow. Well, let's look at our first group. I've got an arrow that's 5 long, an arrow that's 3 long, an arrow that's 2 long. 2 is in TWO, not TOO. It's not longer than I need it to be. Well, I can do another subtraction for this one. This one is 5 minus 3 is equal to 2. But this time it's my first number minus the length of my second one, because I was doing 5 plus -3. Oh, but wait a minute. It's my longer arrow minus my shorter arrow. So the length that represents the sum is equal to the difference between my longer arrow and my shorter arrow. And something to remember, that the lengths of these arrows, what are they determined by? The lengths of these arrows are determined by the absolute value of the number it's representing. This red line here, this red arrow, is 7 long because the absolute value of -7 is 7. Now, what's the relationship, this next part is asking us, what's the relationship between the direction of the arrow representing the sum and the direction of the arrows representing our two addends? Well, this one's a little bit tricky because my two addends, they're facing opposite directions. So, well, my sum is pointing to the left here, and one of my two arrows is pointing to the left. Which one of these? Okay, well, it's the one that's 7. Okay, let's see if there's anything similar between the one that we did before. Okay, well, this one's pointing to the right, and one of my other arrows is pointing to the right. It's the one that's 5 long. Wait a minute, the one that's 5 long, that's my longer arrow. And my arrow that's 3 long. My arrow that's 7 long, that's longer than my other arrow. My other arrow is only 4 long. So my sum is pointing in the same direction as my longer arrow. The arrow that represents the sum points in the same direction as the longer arrow. And another thing that I could say is it points in the same direction as the addend with the higher absolute value. Because remember, the reason that arrow is longer is because its absolute value is just a greater number. The absolute value of -7 is 7, which is a bigger number than the absolute value of 4. The value of 4 is 4. 7 is going to be greater than 4. Then it says, hey, write a rule that's going to give the length and direction of the arrow representing the sum of two values that have opposite signs. Well, basically, we're just going to have to combine what we've done here for 1 and 2. I'm going to put them together into a single sentence. That's going to be the length of the arrow is the difference of the, well, I could say the longer arrow and the shorter arrow, but I want to do this in terms of absolute value. So I'm going to say it's the difference of the absolute values of the two addends. And the direction of the arrow is the direction of the arrow of the sum, but I'm going to leave that out, is the same as the direction of the addend with the higher absolute value. Oh, that cuts off a little bit. That's annoying. Well, I can make it not cut off. There. Now it doesn't cut off. So the length of my arrow is going to be the difference of these absolute values. Remember, 7 minus 4 gives us 3. So the length of my arrow is going to be 3. The direction that my arrow goes is going to be the same direction as my addend with the higher absolute value. So since my 7 has the higher absolute my -7 has the higher absolute value, it's going to go in that same direction. It's going to go to the left. But we don't want to talk about this in terms of lengths of in directions of arrows. We want to talk about this in terms of real numbers. I don't want to have to use my number line all the time. So right underneath this, you should be able to see that rule that puts it in terms that aren't just on a number line terms. The rule says when I am adding together numbers, rational numbers, with opposite signs, I'm going to, instead of adding together my absolute values, I'm going to subtract the absolute values and use the sign of the integer that has the greater absolute value. So when they had the same sign, I added together the absolute values. When they have different signs, I'm going to subtract their absolute values. You might remember that we did something very similar to this back in the last module, back in one of our 6th grade modules. We did something very similar to this when we were working on the length of line segments on our coordinate plane. So now what you are going to need to do on your own, you are going to work on exercise 3. Once you are done with exercise 3, that's all you are going to do for today. So as a reminder, just in case you didn't pause the video earlier to work on your work, that's going to be exercise 2 and exercise 3. That is your work for today. Now I will see you guys all tomorrow. Everybody have yourselves a great rest of your day.